Hello everyone, for this video we're going to talk about the segments of secants power theorem, and this would be our theorem 116. Now, we do have our learning target, which is I can identify the lengths of the secant segments which intersect in the exterior of the circle. Now, after watching the video, hopefully you can answer the following guide questions. First, how will you find the lengths of secant segments? Specifically, if the secants intersect at the exterior of the circle. And how are the lengths of the segments related when two segments intersect? Okay, so we have Theorem 116. What is it all about now? If two secants intersect in the exterior of the circle, then the product of the length of one secant segment and the length of its external part is equal to the product of the length of the other secant segment and the length of its external part. Now let us have sample illustrations so that you can understand thoroughly. Okay, given this illustration, as you can see, we do have two secants that intersect at the exterior point. What are the two secants here in our illustration? We do have line AC and line AE. They are considered secants since they intersect the circle at exactly 2 points. Okay, now, if we are asked to find out the length of the given secants, given that they intersect at the exterior point, then we are supposed to apply Theorem 116, which is based on the description a while ago. We can have this formula or equation. So we are supposed to get the product of the secant and its external part, and it should be equal with the product again of another secant and its external part. Now, so let's say, for example, let's put data on the given illustration. So let's say segment AB is 4. So I'll not make use of unit of measurement for a while so that we will be able to focus with the numerical values itself. So for BC, we can have 6, and for AD, let's say 2. And you are asked to find out the length of line segment DE. Now, of course, based on Theorem 116, we are going to apply this equation or formula. Now, let us substitute already. So, based in our given data, the length of segment AB is 4. And the length of secant AC is what? So, do not get confused. Maybe some of you would write 6, but it is not correct since we are asked to put the length of AC. Therefore, we are supposed to add 4 and 6. So, that means the length of segment AC is 10. Okay, next we have for AD, it's 2. Okay, and how about the measure of the secant AE itself? Now, same with what we did though with the length of secant AC a while ago, we are supposed to add this one. So here, since we don't know yet the measure of segment DE, which is supposed to be added to 2, let us represent this length of DE as variable first. So let us use X, and supposedly it should be added by 2. So based here in our illustration. Now, we can now proceed with the next step. Let us multiply 4 times 10. We can have 40 equals, then monomial multiplied with binomial. So we can have 2 times x, we can have 2x, and 2 times 2, we can have positive 4. And of course, we need to isolate the 2x, or we are more common with the shortcut, which is transposition. So we are supposed to combine like terms. I'm gonna transfer positive 4 to the left side, and we would have negative 4. So 2x remains at the right side. So 40 minus 4. So we would have 36 equals 2x. This is not yet the final answer. We are supposed to apply multiplication property of equality, but we are more particular with the shortcut again, and we divide both sides by 2 to isolate the x, and thus we would have 36 divided by 2. It's 18. So therefore, we can conclude that the measure of this segment DE is 18. And we're done. So you take note, if you are asked to find the measure of the given segment only, or to find the measure of the entire secant, or you take note if you are supposed to find the value of x only. Now, aside from this, you can make use of other process as long as we will arrive with the same answer. Okay, so we're done with this example. Let's move on to the next one. Okay, so let's have this practice exercise. Okay, next we have here, before we start our solution, so better if we write our given data here in our illustration, so that it will help us analyze the problem easily, or else make the necessary solution afterwards. So we have here, so AC is 16, so I'm gonna write this way so that I will be guided that it's the entire secant, which is 16, and we have for BC is 7 here, and for DC we have 8. And now we don't know this one, so you may use the theorem 116 again, since as you can see we do have two secants that intersect at the exterior point, which is point C. Now, since I guess you can now analyze the given scenario, and now let us make our equation or formula based on the given illustration. So applying theorem 116, let us have the product of the secant and its external part. So secant AC times external part is BC, and it should be equal with the product again of another secant, so EC times the external part, which is DC. Okay, now since we are done with our equation, let us now substitute the given data. For AC, we do have 16, and for our BC, we do have 7. Okay, next we have for our EC, since we don't know yet the measure of segment ED, which is supposed to be added to 8. So let us represent it first using variable x and then added by 8. So this would be the measure of the segment EC multiplied with DC, which is 8. Okay, now let us multiply 16 times 7. We would have 112 equals, so we do have x plus 8 multiplied with 8. We can use again the distributive property, so 8 times 8 and 8 times x. So actually, we may also have another method I mentioned a while ago. You can use this one. So if we are going to multiply this using distributive property, and then afterwards we are going to simplify for our final answer, right? So that means you can do the shortcut by, instead of multiplying it, you proceed now with simplifying it already. So you isolate x plus 8 by dividing both sides by this factor 8. So we can now have remaining terms here would be x plus 8, and then 112 divided by 8, it's 14. Now, so combining like terms, we can have 14 minus 8 equals x, and thus 6 equals x. Now, this is our value of x. And since we represent the segment DE as our variable x, now we can conclude that the measure of the segment DE is equal to 6 already. But since, according to our problem, what is the measure of the secant EC? Okay, therefore, our final answer would be EC equals 8 plus 6. It's 14. And therefore, this would be your final answer. EC is 14. Now, we were not able to use unit of measurements in our examples, but take note, during our exam, if the given illustration, I make use of unit of measurement, therefore, for your final answer, you must put unit of measurement as well. So since here, I did not use any unit of measurement, therefore, our final answer would focus only with the numerical value. Okay, so last more example on this. So we have, again, my tip is you start with putting the labels or given in our illustration so that you can easily distinguish the data here in our illustration. AB is 8, BC is 10, DC is 9, and you are asked to find, again, the measure of the entire secant EC. Now, we don't know, again, the measure of DE. So, since we do have two secants that intersect at the exterior point C here, therefore, we are supposed to apply, again, Theorem 116. Now, let's start with our formula. So, secant, so AC multiplied with its external part, which is BC, and it should be equal with the product again of the secant EC and the external part DC. And now let us substitute already. AC is what? Do you think it's 8? Is it 10? Okay, so since we are asked for length of the entire segment AC, therefore we are supposed to add 8 plus 10, it's 18. Next, we have BC is 10. Okay, and we do have EC. Since we don't know yet what are we supposed to combine with 9, so let us represent it as x plus 9. Okay, and multiplied with the length of the external part, which is 9. Okay, now let's multiply 18 times 10. We would have 180. And I'll just simply copy x plus 9 here. And instead of multiplying or applying distributive property here, I'm going to proceed with simplifying already. So I would divide both sides by 9 to isolate x plus 9, or to simplify it already. 180 divided by 9, it's 20. And now let us combine like terms to isolate the x here. So 20 minus 9. And lastly, we would have x equals 11. Okay, but take note, I am looking for the length of EC, not the value of x only or the measure of DE only. So here, since we represent DE as our variable x, therefore we can say that ED or DE is equal to 11. And since we are asked to find the measure of secant EC, therefore we should know the entire measure of this secant ED and DC. So 11 plus 9, therefore our final answer must be EC equals 20. And we are done with this problem. Okay, so let us have our seat work. You may pause the video for a while, and if you are done answering the given activity, you may now proceed to check your answer. So here's the given illustration. So we do have here 5 given illustrations. So reminders before you start answering this, we may also apply the idea of factoring again. If it involves quadratic trinomial, you may apply factoring, and take note, if the quadratic trinomial is not factorable, then you may conclude for that item there should be no solution. So you just put note there that no solution if it involves quadratic trinomial and it is not factorable. Okay, so if you're done answering, now you may resume watching the video to check your answers. So we have here for number 1, we have x equals 23.33. Letter B, we do have x equals 0.1. For letter C, since the quadratic trinomial there is not factorable, then we may put the note that there would be no solution or not factorable. Next, for our fourth item, x is equal to 2, and lastly, x is equal to 9. So that's it for this video. I do hope you learn about Theorem 116. Thank you so much for watching, and see you on our next video lesson.